Hello everyone and welcome to this another supplemental video. My name is Kasanas. Guys, this series is really in support of a course that I'm teaching. We'll be looking at several different practical and technical details of Unity and scripting. So if you're following along, fantastic, that's great. In the last episode, we just took a look at Unity. We kind of explored Unity and the hub. And in this episode, we're going to take a look at some really basic scripting. All right, let's get started. Okay, everyone, here I am inside of Unity. I've started a brand new project. I simply called it Game Dev 1, and this is the project I'll be using throughout this series. Whenever I update or have to make a new video for this series, I'll just simply update this project. You guys should be able to follow along, create yourself a brand new project. I haven't done anything inside of here yet, with the exception, of course, of creating a couple of folders that I'll be using to make sure that I remain organized as I'm moving forward. If you wanted to create a new folder or anything really, and you didn't know how to do so, select your project tab, and then anywhere inside of the gray, you can either right click and say create, and you'll have a bunch of options here, or you can go over to the little plus sign, and right here you'll have a bunch of options as well. Really, really easy to create anything you want. Let me create a new folder right now. I'm going to right click. I'm going to say create. I'm going to find the folder option. And let's say I want to store some animations in here. I can simply rename that folder and bang, there we go. I've got myself a brand new folder. And I think it's really important, guys, when you're first starting off to really be organized. We're not going to do anything complicated in the series. It's going to be really rather simplistic, but remaining organized as you're moving forward in your larger projects is really going to help you out. So I recommend starting a couple of different folders, make some different folders that you think you're going to need. I created a scripts folder and a sprites folder. I really don't need a sprites folder right now. The only thing we're going to work with today is our scripts folder. Okay, we've got a bunch of things that I'd like to cover though, so let me tell you what we're going to cover in today's episode. For some of you, this is going to be your first look at scripting. We'll be looking at mono behavior and the options we have with mono behavior. Particularly, we're going to be discussing the idea of C#, creating comments, examples of primitive data types, the start and the awake function, as well as additional functions like the update, the fixed update, and the late update, and custom functions as well. So this might have to be broken up into two videos. I'm not sure yet, depending on how long it goes. But yeah, that's what we're going to be covering today. Okay, so let's get going. So we're going to create our first script in the same way we created our folder a moment ago. We're going to go into our scripts folder. I'm going to start off inside there. And again, I'm going to stay organized right away. And I'm going to right click anywhere inside of this projects tab. And I'm going to say create. And I'm going to find the scripting option. And you can see that in the scripting option, we have a number of options available to us. The one we're interested in is mono behavior script. So just scroll across and click the mono behavior script. And you can see that I've got a script that started up here and it has no name right now. It just says new mono behavior. And I'm going to call this week 2 scripts. It's probably a terrible name. Maybe I should have thought this through, but that's what we're going to call it, week 2 script. And when I do, it renames and it goes through and does what it has to do in the background. And if I want to open this up, I can simply double click and it's going to open it up. I'd open it up over here in the other window. Here we go. I open it up over here inside of our Visual Studio editor. That's what we're going to be using. We're using Visual Studio here. So let's take a look at what I've got. I've got a bunch of stuff that's already inside of here, and we're going to talk about some of this stuff as we move forward. At the top, it says using Unity Engine. This at the very, very top, so right now only on line 1, we have libraries that have been made available to us. So anything that's available with inside of Unity Engine is going to be available within the script itself. We are going to update the using lines as we move forward. As we need more things, we'll add more libraries that are going to be available to us. So that's going to be added here. We're not going to do that right now. We don't need anything extra at this point in time. But let's take a look at the structure of this script. Let me just make this a little bigger. Let's take a look. I've already got this as big as I can. I don't want to work any larger than this, so if you can't see it, I really apologize. But it's already pretty big. So let's take a look at what we've got here. Right at the top, we have this public class week 2 script mono behavior. We have a brace or an open bracket here, and you can see we have a matching closed bracket down here. If you highlight one bracket, you will see the matching closing bracket. as well. So if I highlight this, boom, I can see the one down there as well. This is really, really important. Everything within this bracket is going to be available within this class. We'll talk a little bit more about classes later on. For now, we're just going to stick with the kind of technical stuff that is associated with this particular lesson. So as long as everything is falling kind of between these two braces, it'll be included within this class and available to the week 2 script. That's what's really important. I want to start off by talking about comments. We'll talk a little bit about comments here, and we can see we've got a number of comments already. In fact, we can see we've got a number of different things. We have a comment right here and down here as well. We also have a couple of functions that are automatically created for us whenever we started that brand new mono behavior. We started off with a void function, sorry, a start function, a void start function, and a void update function. And we're going to talk about both of those a little bit later on. We're going to start off, though, by talking about the idea of comments. And comments is kind of a controversial issue depending on who you're speaking with, because for some people, the idea of commenting their code is a little bit ridiculous. If you've got what's called clean code and you've used appropriate variable names and you have, well-written code, you shouldn't require comments to be able to explain what's happening. I don't think like that. In fact, I think that you should have a number of comments that are made available immediately within every single one of your scripts. I'm not telling you to over comment, but comment anything that you think is complicated and needs explanation. But what I do believe, and I think this is extremely important, I've already got this over here. I've copied a comment. Let me see over here. Let me just copy this. And I'm going to place it right at the top of my script right here. I'm going to place it. So what I've got here, this is a comment, and this is a multi-line comment. You have a couple of different choices when you're creating your comments. You have the multi-line option. So it starts with a / star and ends with a star \. And everything in between there is the comment itself. So if I wanted to add something else in here, so I hit a space, you can see there's automatically a star here, and I can say hello, hello, like that. You can add anything you want in your comments, and as you make additional space between the / star and the \ star, it'll continue to add that as an additional comment. I like to add a comment like this at the top of every single one of my scripts. And the reason why I add this is in case someone else later on is looking at it. But not only that, I like to organize my thoughts in a comment at the top of a script. This is not super important right now. I've just kind of got a comment that says, discuss comments, which we're doing right now, go over examples of primitives, examples of start and awake function, and examples of the functions themselves. So anyone who opens this up can really right away see what is going on in the script. But further, it allows me to organize in my own mind what I'll be doing as I'm writing this script. I often like to write logic in here, or pseudocode really, that kind of explains exactly what something's going to do. If I've got myself a custom function of some kind, I might say custom function and explains exactly what it does. Okay, and this is really important, I think, not only for a person who's reading this later on, but for you as the coder as well. One of the biggest mistakes that a new coder makes is actually writing code. They sit down and they immediately start to write their code, and they haven't gone through the process of considering what that code needs to be yet. They just sit down and they start writing. And I think by starting off with a simple comment at the top that goes through your logic and lets you say, number one, I'm going to do this, number two, I'm going to do that, and you follow through that, you're going to be able to write your code a lot cleaner. You're going to, instead of just kind of making it up on the fly, you are going to have a nice, clean logic, and you're going to be able to follow that logic through and write your code appropriately. Okay, so that is a multi-line comment. You can have additional comments like this one right here. So a / and then anything you want. So if I wanted to add a new comment right here, / this is a single line comment. So I'll just say single line comment, just like that. And any of your comments, so any of the stuff that's written in green on my screen, will not actually be involved in the compilation. It's kind of ignored. Anything that's a comment is ignored during compilation. It doesn't take up extra space. It doesn't make your actual end file any larger. So you can comment as much as you want. Now, again, my recommendation is a comment on top that has all of your logic and what you're going to be doing within this particular script. and then only commenting things later on that are extremely important. So if you have something that you think is going to be confusing to someone reading this, or maybe even confusing yourself later on in 2 years from now when you open the script up, you can comment that as well. Add in a simple comment that just tells you exactly what it is. And you can see that Unity has already gone through and added in a couple comments for me. It tells me exactly what the start function is and exactly what the update function is right here. Okay, so that is the idea of comments. The next concept I'd like to cover today is the idea of variables. And we're going to go through some primitive data types that are available within within mono behavior, excuse me. And we'll, discuss a couple of key ones as we're moving forward. So we'll start off with the idea of an int. An int is any positive or negative whole number. And by declaring an integer, I am setting aside a specific amount of RAM that's going to be available to this script to store that information. Depending on the data type that you are actually creating, a different amount of memory will be allocated for the storage of that particular variable. Depending on where you create that variable, the variable may be available throughout the entirety of a script or within a specific portion. This is known as scope. So let's take a look at what we've got here right now. We have our bracket up here. That's the start of our week 2 script. And we have our end brace right down here. Anything that's declared between these two braces outside of additional braces that we have, so anything kind of declared anywhere within this mono behavior script outside of the additional braces is available to the entirety of this script. So if I declare something right in this section here, it's going to be available to the entirety of my script. However, if I declare something inside of the braces of my start function, then that variable will be only available to the start function itself, and that memory is deallocated once we are done with it. Same thing is true down here in the update. So if I declare something in the update, the memory is allocated each update and deallocated when we are done with it. So we'll talk about that a little bit more later on. But just understand for now that the idea of things being declared within braces defines the scope in which that variable is available. Let's start at the top right now. We're going to declare ourselves a handful of variables up here. We'll start off with the idea of an int. And in order to declare something, you can either start off with a keyword. For now, we'll talk about the idea of something being either private or public. We won't go into any other additional options. So something's either private or public for now. And if it's not explicitly declared as public, then it is considered private. Now, what does this mean? What does private and public mean? So let me start off by saying, first of all, int. And this is going to be a brand new integer. An integer, as I think I've mentioned, maybe I haven't, an integer is a positive or negative whole number, and it's allocating a specific amount of RAM available for this storage of this particular variable. Let me call this my first int. I'll call it that, and I'll end with a semicolon here. So in declaring this integer called my first int, outside or within, sorry, the braces here, it's going to be available to everything that's located within these braces. So my first int is available in start, and it's also available in update. And because I didn't start with a keyword, and let me show you the opposite, I'm going to say public int, and I'll call it my second int. Here we go, just like this. By saying something is public, again, this has been declared within the initial braces. It's available everywhere. Now, the first one is private. The second one is public. A private variable is not accessible to functions or scripts exterior to the one I've got here. So if I create another script and I'm trying to read my first int, I can't do it directly. I have to do it through something called an accessor function. So something that will read this script and return it to another script somewhere else. Anything that is made public is available to other locations. Another script can call upon my second int. It cannot call upon my first int. It can only call upon my second int because my second int is public. By not utilizing a keyword in front, and I could have said private here if I wanted to explicitly say this is a private variable. By explicitly saying like this, I'm declaring this as private. By leaving it blank, it's automatically assumed to be private. It's automatically created as a private variable. So as I've already mentioned, the int itself is any negative, or positive whole number. There's a couple of different ways to declare it. You can see here that I have not defined uh, I have not actually defined what this variable is right now, the value inside of my first int. I haven't gone through and explicitly indicated what it was. I've made a declaration that this is an integer, but I haven't initialized it yet. If I wanted to, I could have gone through and I could have given a value to this in my declaration. I could have said int, my first int, and I could have said equals, and I could have given it a value, let's say 10. Okay, so whenever I try and access my first int, it will be initialized with a value of 10. When I try and access my second int, it'll have the value of 0 associated with it. There is some kind of initial value or null value that is associated with every single variable that you create. So in this particular case, my first int will have a value of 10. My second int will have a value of 0 because that is the default value that's associated with an uninitialized integer. Just like the integer, we have the idea of something called a float. So I can declare a float as a float, and I could call it my first float if I wanted to. And again, if I wanted to, I could either declare it public or private. I could initialize it right here with a value. A float is any number, again, up to a certain amount of space within memory, any number, any decimal number. So I could have said my float equals 1.2. Now, if I leave it like this, you can see right now this is saying, hey, nope, there's a problem here. This red underline suggests there's a problem. If I'm declaring something as a float, even though I've declared it as a float here, I have to add an F afterwards, after the value, to say, hey, I want you to use that decimal place as well. So a float, again, is any value, positive or negative. It doesn't have to be a whole value. It can be a whole number. It can be any kind of value you wish. The double is another option. I won't go through and declare this, but the double is very similar to a float, but it's much larger. It has much more memory allocated for it, so it can hold much larger numbers. We have an option called a car. Oops, I should not have hit return there. We have an option called the car or the character. So I can declare a car like this, a character like this, and I could say my first character, and I could say equals, and you can see it's already telling me how I have to set it up. It's suggesting that I have to use these single quotes. So I can say equals, and then I can use the single quote, and oop, that's not single quote. That's not single quote. Where's my single quote? Right here. That's double quote. I'm trying to look over my microphone at the same time. There's my single quote, A. So I can do this, and now I have declared my first character to contain the value of A. You can put any kind of value you want in there. You can put a numerical value. You can put special values in there as well. We won't go in depth into that. That's going to be something you will do later on. It's probably going to be made available to the students within their labs. We'll take a look at some of the different string ideas, working with strings later on, which brings me to the idea of a string. So an array of characters is called a string, and I can create a brand new string by declaring string and then saying my first string, and once again, I can either declare it with something, so I can say equals. In this particular case, I'm going to use the double quotations like this, and I'll say hello world to go back to the old days when everything was our first hello world script. All right, and you'll notice at the end of each of these, I've delimited it with a semicolon. If you leave the semicolon out like this, it will not know where this value ends, where this actual line of code ends. It's giving me an error right here. You can see I'm seeing my errors right down here in the error list. Afterwards, I can either click on it and see exactly what this is associated with. It might make some suggestions. In this case, it's saying, I expected you to have a semicolon, and I don't see one. And I can add in my semicolon there, and that will clear up. Okay, we'll take a look at one more simple primitive data type, the bool. So the bool is a true or false. That's all it is a true or false. It can have a value of 0 or 1, or it can have a value of true or false. I'm going to say my first bool, and again, I can initialize it as it's suggesting here, is equal to false. Now that we've declared some of these variables, what can we do with them? Well, let's start off really, really simply by just printing them out so we can see exactly what they look like. it's going to bring me to talking about the idea of the start function. So let's access this now. I'm going to go down to the start function right down here, and I'm going to use something called the print function. So I'm going to use print, and I'm going to start off with a bracket, and I'm going to print something out. And you can see that I'm given a number of different options here, or I can start typing my first. I'm going to print out the first string. So my first string, I'm going to print this out. I'm going to hit tab to close my bracket and add the semicolon. Now, if I save this, let me file save this, file save all. And let me just move this out of the way. Okay, so down here we have our week 2 script. If I click on it, over in the inspector, I can now see week 2 script has been saved. Everything I've written in there is located here. I can see print my first string. If I hit play, you'd think that it's going to print my first string. It's not going to, but let's just hit play and see. Okay, so first of all, my game screen has taken over the screen. I don't actually want it to do this. My game window's taken over the screen. I don't want to do this. Down here, I would have seen where it said, hello world. It would have said down here, hello world, if this had run properly. It didn't. Let me just turn this off for now. So down here in the game window, you can see play maximized. I'm going to turn this off and say play focused, which means it'll stay here. And what I'm really interested in right now is this console, because this is where all of our stuff is going to show up. So the reason why we're not seeing my first string printed out and hello world printed out is because this script is not actually within the hierarchy at this time. It's only located right down here inside the project. If I want this script to run, I have to add it to a game object within the scene. When I do so, it will then access all the functionality of the script. So let's start off by creating a brand new game object. I'm going to go up here to the menu and say game object, and I'm going to say create empty. And this is going to create an empty game object that I will call my first my first object, I guess. My first game object. Terrible names. But here we go. Here's my first game object. And right now you can see that my first game object was selected, and over here in the inspector, it only has a transform node associated with it. If I hit play now, again, nothing's going to happen. I can see this object's action in the world. If I click on the tools up here, I can see that this object's here. There's nothing associated with it. It's just kind of an empty nothing thing right now that I can move around and I can scale. It doesn't really do anything though. If I want it to do something, I can add a script to it or I can add other nodes to it. I'm going to add the script, and there's a couple of different ways of adding a script. You can either say add component, you can say add a brand new script, and add the script that way. Let me get rid of this. Sorry, either add a brand new script instead of creating it down here. We could have added a brand new script and directly associated our script with an object immediately. I could go down here and I could find scripts, and I could then find my script, my week 2 script down here, and add it that way. Or if I want to, with it selected, I can drag and I can drop this in place and it's going to automatically add that script. Now there's a couple of interesting things that we see right away in adding this script. First of all, for some reason, my second int is showing right here. It's showing as 0. Okay, that's pretty interesting. Let me drag this back so we can take a look at it. If we take a look at my second int, I think I said first over here. If we take a look at my second int, the reason why we're seeing it inside of the inspector in Unity is because we declared it as a public variable. Any of your public variables can be manipulated right here inside of the inspector. So I can actually give my second int a value right here, even though I haven't initialized it. When we wrote the code, we hadn't initialized it, and I told you it would have a value of 0 initially. I can initialize it right here. Now, the great thing about declaring something public, and there's other options that are safer, but for now we're only looking at private and public. By declaring a variable as public and making it available to me inside of the inspector means I can change it as my program is running. So if I wanted this thing here to change over time, or I wanted to adjust its value without having to stop and then restart the script and et cetera, et cetera. Instead, I can just change the value right here. I don't have to open up the script at all. I can change the values right here, and it's automatically going to update appropriately. Okay, so that's one of the first things that we see. Now that we've added this script to our game object, and that game object exists within our scene, within our hierarchy, Now, inside of this console, when I hit play, watch what I can see. It's going to access the start function, and it's going to print hello world. All right, so we can see that the functions, let me just stop this. I should have stopped that first. We can see that the variables that I've declared up here can be utilized anywhere within our script. So right down here in my start function, I utilized the print my first string. We're going to take a look at a couple more variables right now. Let's take a look at the idea of something called an enum, and I'm going to add it right in here. So an enum is declared by saying enum. It's an enumerator, and an enumerator allows us to associate words, words really, with particular locations, particular values. So let me give you an example. It's actually easier for me to give you an example. I'm going to declare a new enum that I'm going to call week. I'm going to call it weekdays. Let's just call it weekdays. All right, and when I declare this new enum, I can add in a brace, or to my two braces. And within these braces, I can now add in new words. So I can say Monday, comma, Tuesday, comma, et cetera, et cetera, et cetera. Wednesday. We'll just stop with those three for now. Monday, Tuesday, Wednesday. And of course, I can add in as many as I want here, separating each one by a comma. And in doing so, I need my semicolon at the end. In doing so now, I am suggesting that whenever I access weekdays, I can declare a variable around the idea of weekdays, and I can assign it one of these base values. So as a quick example, let me say, let me actually add Saturday in here as well. Okay, so let's go down here, and I can say, I can declare now a brand new weekdays. This is the name of the enum, and I can give it a variable name. So I can say the best day of the week. All right, and I can say now, it's giving me an example here, equals, and I can give it any value I want from weekdays. So let me just get rid of this for now. Weekdays, and when I say dot, it's automatically going to give me the choices that I added into my enum, Monday, Tuesday, Wednesday, Saturday. You can see all those here. And obviously the best day of the week is Saturday. I mean, maybe it's Friday. Who knows? It's one of those days. It's for sure not any other day. But it's one of those days. So I can go ahead and I can declare a brand new variable based on the enum weekdays, and I can assign it a very specific value. And I can use this. I can later on we'll talk about logic and being able to examine different logic points and switch based on particular values or particular return results, etc. I can branch off to different areas of code. I can actually use this now to do so. So every time a Saturday comes up, maybe something's going to happen later on in code. All right. And every time we declare a new weekdays, so weekdays, and I'm going to call this first day, and I'm going to say equals Monday in this particular case. So I can go ahead and I can declare each one of these, and then I can declare, I can access each of these values based on these variables I've created. All right, and I can assign each one to a different one, or I can make one that's unassigned. So later on, I can say weekdays, and we'll call it random day. Oops, random day. And I won't actually initialize it. So later on, I can assign it a value from my enum, Monday, Tuesday, Wednesday, Saturday. Okay, this is an uninitialized value that I can assign later on. Enums themselves, I haven't had cause to use them very often. I know lots of people who do, and they use them very frequently whenever they're looking for something. Let's say they're creating, I don't know, cardinal directions or something like that. They might use an enum to associate those cardinal directions, north, south, east, and west, or something like that. They might use for very particular circumstances. I personally don't use enums all that often at all. But I want to make sure you guys are aware of them. Let's take a look at another slightly more complicated variable type, vectors themselves. Let's talk about vectors. And there's several different types of vectors. You can have vectors 1 all the way through whatever, vector whatever. If I want to create a new vector, and I'm going to call this vector 2, let's say, I'll create a brand new vector. Oops, I didn't put the whole thing. I'll create myself a brand new vector 2. A vector 2 is going to be a value that contains two numbers, an x and a y coordinate, let's say. All right, now once again, I have to declare what I'm starting. I'm starting a vector 2. I'm going to declare the variable itself. So I'll call this my first vector. And I have to declare this slightly differently than I would something else. I have to use something called a constructor. And a constructor is going to allow me to automatically build this vector. If I haven't initialized it, it's fine. But I'm going to be initializing this particular vector utilizing something called a constructor. In order to use a constructor, I have to say, exactly as it's listed here, my first vector is equal to new vector2. Okay, and this is going to set aside the appropriate amount of space again in memory for this vector 2. And I can initialize it, so I can give it an initial value of, let's say, 0 and 1. And in doing so now, my first vector, when it's created using this constructor, the new keyword and this constructor, will create a vector 2 that contains the values in the x and the y coordinates as x equals 0 and y equals 1. Okay, and later on I can use that. So if we are trying to calculate space, or we're trying to find a grid location, or anything that you might use a vector to for, direction of travel, anything at all that you might use a vector for, you'd go ahead and create in this manner. And you can create vector 3s or vector 1s or anything else you might like. Okay, uh, I think the very last variable I want to talk about today is the game object itself. And I want to show you that we can actually create new game objects as well. So just like we created this game object over here inside of Unity, we called it our first game object. Just like we called it that. Is this the right one? No, this is the right one over here. Just like we created a game object there, we can create a game object in code. All right, so let's go ahead and declare ourselves a new game object. Let's make this a public game object. So public. And I'm going to use the keyword game object. You can see as I start to type, it shows up right at the very top, right here, game object. And I'm going to give this, my script game object, I'll call it. And I made it public. I won't actually declare what it is. And let's see what that does for us. Okay, we're going to see what this does for us. So I'm going to save this, file save. I've only created this enum, and I've created this vector2, and I've created this new public game object right here. I'm going to save this, and I'm going to move it out of the way. And now if we take a look, let's just clear these off for now. Those were all warnings saying I've created a bunch of things that I haven't used, and I know I haven't used them. It's okay. If we take a look now over here in the inspector, you will see that I can now see my second int because it was public. It had a value of 0. And I can see my script game object. It has a value of none. There's no game object associated with it. I'm going to create one more game object right here. Game object, create empty. And I'm going to call this, I'll call it my in-game object. I'll just call it that. In my project, with my first game object selected, over here, my script go, I can actually associate this thing I just created with this object. Let me grab it and drag it without letting go and drop it here. I've now initialized this public my script game object with the value inside of in-game object. And you know what we'll do just to test this out? Let's go over here. Let's go back to our script. Let's go back to our start function, and I'm going to say print, and I want it to print out. My script go. So it's going to now associate whatever I've got over there. So whatever I called it, in-game object. It's now going to print that out. It's going to show us that. Okay, let's file save this. Let's move it out of the way. Let it do its thing there. Let's go to our console. These are all warnings saying, hey, you didn't assign any values. You didn't do anything with this. I'm just going to clear those for now. There was no errors. If there was errors, I'd have to deal with them before this ran, but there were no errors. Now when I hit play, you're going to see that it's going to say, hello world, and it's going to print in-game object, which is this. It's telling us that if we go back to here, that our MyScriptGO is associated with the in-game object, and we are seeing that right here. I think what might make sense is to end this video here. And the reason why I'm suggesting that is because I don't want to cover too much in a single video. I find that lots of times when my students are watching these videos, they've got about 15 or 20 minutes in them, and then that's it. And then they kind of fall off and they lose interest. So I think what we'll do is we'll end this first video for this week right here. And I'll put up multiple videos this week all at the same time so you can watch them if you wish. What I'll be doing is in the next video, I'll cover some of the other ideas I want to take a look at, particularly the idea of the start function versus the wake function. And then I'll either talk about other functions in that same video, or I'll make a third video for the week, depending on how long that gets. Like I said, I don't want anyone to get burnt out on these. These are all about learning really basic stuff and then applying it practically. So my recommendation to you is to go through right now, utilize, let me just drag this back so you can see it, utilize the print function that I taught you. Go through and declare several variables. Try printing out those different variables. Try declaring it in different ways. Practice the declaration of your variables and accessing them through the start function for now through the print. Give that a try, give it some practice, then move on to the next video, which is going to be discussion about start versus awake. All right, everyone. I hope you guys enjoyed it. If you did, let me know down below with a thumbs up. If you think I cut this off too early and that you would have been fine going on for a much longer video, let me know that as well. Like I said, I don't want anyone kind of spacing out and losing interest and then falling off the video. These videos are extremely important for my students. In many cases, my students have never accessed Unity before, never coded before, so a lot of these technical videos are going to be extremely important to them. I'm making these videos for my students for them to be able to learn this material. So let me know down below if you liked it. Thumbs up, thumbs down. It's up to you. It doesn't really matter to me. Like I said, I'm just doing this for fun and for my students. All right, everyone. Thumbs up, thumbs down, comments down below. And if you haven't done so, please take a few seconds to subscribe. You don't have to. I don't actually really do this anymore. But if you want to, you are more than welcome to still subscribe. All right. Thank you.